So, good evening. My name is Narasaiah. I'm working in Mlritm as assistant professor, and today our topic is design analysis of algorithms. In this chapter, I want to explain about introduction to algorithms. So, what is an algorithm? It is a finite set of instructions which are used to solve a problem. So, algorithm means any work with a set of instruction we are doing, that is called an algorithm. Example, if I take making chai or tea. So first step, what we have to do, we have to take water, milk, chai pata, then stove is needed, then we make a tea step by step. So what this work is given for us, we are doing with a step by step process, that is called an algorithm. So algorithm of example if I say adding two numbers. First step, start adding two numbers. If we take first step is starting the adding of two numbers. Second step is declaring variables. So if you want to add two numbers, we need two variables, and we have to store that addition in another variable. So we need three variables. Third step is input numbers. Fourth is performance to perform addition. Fifth step is displaying result. Sixth is stop. So this is the example of algorithm. Next, how we calculate performance of an algorithm? By using these two components, we can calculate performance of an algorithm. First one is time complexity. Second one, space complexity. What is time complexity? What is space complexity? By using these two parameters, we will calculate the performance of an algorithm. Time complexity. If we take, previously we see the example of addition of two numbers. To add that two numbers, we need some amount of time. To process that algorithm, we need some amount of time. That time is called time complexity. So to store the space, that variable we have to store somewhere. So the space is required. That space is called space complexity. Simple way. Next. So that is what written here. The amount of time an algorithm required to complete its execution is known as time complexity. And these are this time complexity are the three types: best case, worst case, average case. Best case means if an algorithm requires minimum amount of time for its execution is called best case time complexity. And if an algorithm requires maximum amount of time for its execution is called worst case complexity. And if an algorithm requires moderate or average time for its execution is called average time complexity. So these are the types of time complexity: best, worst, and average case. By using these three parameters, we can calculate the performance of a time complexity. Simple. Next, the amount of space an algorithm requires for its execution is called space complexity. When we calculating space complexity, we use the following rules. First one, for comments, declarative statements, the step count is 0 we take. And second step, for any looping statements, step count depends on the number of iterations. This is the second step to calculating space complexity. And third step is ignoring lower order exponents when higher order exponents are present in the relation. This is the third step of space complexity. Ignoring constant multipliers. We have to ignore the constant multipliers is the fourth step of space complexity. Next one, asymptotic notation. So this is a very important topic in DA. design analysis of algorithms. In design and analysis algorithms, this is asymptotic notations are the very important plays vital role. Why? Because we have to calculate based on this four these four are in the syllabus. In this R20 syllabus we given four only, but here it some textbooks got five types of notations. So first one is a big O notation. In asymptotic notations, first one is a big O notations. Second one is small O notations, small or little O notations. Third one theta notation, and fourth one is big omega notation. These are the four types in syllabus. We know this in R20 syllabus. We got these four types of notations. So what is asymptotic notation? Asymptotic notations are mathematical representations used to describe the running time of an algorithm. What is an asymptotic notation? The mathematical representation used to describe running time of an algorithm is called asymptotic notations. Based on this topic, we divided asymptotic notation four types: big O, small o, omega, theta notations. So what is big O notation? It represents, big O notations represents upper bound of the upper bound. Example, see the graph. In this graph, upper bound here, this is the upper bound. We call it f of n. This is called big O notation. So big omega notation. What is big omega notation? It represents lower bound of the running time of an algorithm. Usually this big omega notation, we call it a best case complexity, best case time complexity. By using this big omega notation, we can accurately calculate the values of the algorithm. So it is also a mathematical representation. So big omega notations represented by this graph. This is f of n. This is the lower bound. C dot g of n is equals to g of n is called big omega notations. Next one, theta notations. Theta notations represent both lower bound and upper bound. In between, lower bound ke upper bound, in between, whatever this middle point is called theta notation. Thank you so much. For today, this is, we know about introduction, what is an algorithm, how to calculate a performance of an algorithm. Third is asymptotic notations. So we see this kind of introduction. In the next lecture, we'll see deeply. Thank you.